In this video, we talk about section 7.5 Numerical methods for definite integrals. We mainly talk about left rule, right rule, midpoint rule, and trapezoid rule. Now let's start with an example. So this example. For this definite integral, the integral of 1 over x from 1 to 2, find the left 2, right 2, and mid 2, and compare your answers with the exact value of the integral. So now let's first look at the left 2. Left 2 means we divide the interval 1 to 2 into two subintervals with equal length. Delta x is 2 minus 1 divided by 2 is 0.5. So these two subintervals is from 1 to 1.5 and from 1.5 to 2. So here this is the picture of left rule. So the right curve is the graph of the function f(x) is 1 over x. So here we approximate the area using the right triangles. That is, we use the value of the function f(x) at the left endpoint as the height of the triangle. So now let's look at the first triangle. For the first triangle, it has base 0.5 and its height is f1. For the second triangle, its base is still 0.5 and its height is f of 1.5. So left 2 is equal to the sum of these two left 2 is equal to the sum of the areas of these two rectangles. So it's equal to f1 times 0.5 plus f1.5 times 0.5. So we get this is approximately equal to this number. So now let's look at the right rule. Right rule, the picture is here. So this is this right curve is the graph. The function f(x) is 1 over x. So this time we use the value of the function f(x) at the right endpoint as the height of each rectangle. So for the first rectangle, its base is 0.5. Its height, so use the right. Its height is f1.5. For the second rectangle, base is 0.5. Height is f2. So right 2 is equal to the sum of these two areas of rectangles. So it's f of 1.5 times 0.5 plus f of 2 times 0.5. This is approximately equal to 0.5833. So next is the midpoint rule. So for the midpoint rule, we use the value of the function at the midpoint as the height of each rectangles. So let's look at the first rectangle. It has base 0.5, but its height is the value of the function at the midpoint of the interval 1 to 1.5. So this midpoint is 1.25. So the height is f of 1.25. The second integral, its base is still 0.5, and its height is the value of the function at the midpoint of the interval 1.5 and 2. So it's 1.75. So the mid 2 is equal to f of 1.25 times 0.5 plus f of 1.75 times 0.5. So this is approximately equal to 0.6857. So we know how to find the true value of this integral. In fact, So we have the integral of 1 over x from 1 to 2 is equal to ln x from 1 to 2. So it's ln 2 minus ln 1. Ln 1 is 0. So this is equal to ln 2. Ln 2 is approximately equal to 0.6931. So now we compare left rule, right rule, midpoint rule, and the true value of this integral. We get mid 2 is much closer to the true value of this integral than left 2 or right 2. So now this is the left rule, right rule, midpoint rule. Now we move to the trapezoid rule. So for the trapezoid rule, we approximate the area under the curve over this subinterval by a trapezoid. So this is the trapezoid. And the area of this trapezoid is given by this f of si minus 1 plus f of xi divided by 2 times this height theta x. So if we add all the approximation trapezoid together, and we let the trop n be the resulting sum, then trop n is equal to left n plus right n divided by 2. So now let's do an example. So still for this definite integral, the integral of 1 over x from 1 to 2, compare the trapezoid rule with two subintervals with the left, right, and the midpoint rule. So in the previous example, we already got left 2 is approximately equal to this number, right 2 is approximately equal to this one. So the trapezoid rule is the average of this. So trop 2 is equal to this number plus this one divided by 2. This is equal to 0.7083. We know the exact value of the integral is this number. So the trapezoid rule is better than the left or right rules. The midpoint rule is still the best in this example. Since the midpoint rule is 0.6857, it's much closer to the exact value of the integral.